reason I'm calling it basic trigonometry is because we're going to be talking about right triangle math. So we're going to be looking at nice little right triangles and see what kind of stuff we can come up with. So with that in mind, the first thing you're going to need to know if you're going to do anything with triangles, we need to make sure that we know the parts of a regular right triangle. So a right triangle obviously has a right angle. It's going to have that 90 degrees in there. I didn't mean to actually do that. So let's go back, slide. So it's going to have this 90 degree in there. And then the other one that's very important is the hypotenuse. The hypotenuse is one, a lot of people always point out that it's the longest side, and that is a correct statement. But the other part of it is also the side that is opposite your right angle. So, and it only fits, a hypotenuse only pops up when you actually have a right triangle. The other thing I have on here is I have the Greek letter theta. And I'm putting theta on here. This should be an H, because we're going to be talking about unknown angles. And I decided to put it down the bottom so that my side A could be adjacent to that, and side B would be my opposite side. That's just kind of the easy way I felt that would fit. Then kind of keeping going from there, the first thing we're going to have is our SOHCAHTOA. SOHCAHTOA. Let's go back. SOHCAHTOA. And basically what that does is that splits it up into these three parts, which are our three trig functions. So the sine is equal to the opposite side over the hypotenuse. So the sine of an angle, we always take the sine of an angle. We need to know what angle so we can figure out what's opposite, what's adjacent, and what's hypotenuse, that type of stuff. So it would, in my picture, it would be B over C. And then cosine is adjacent over hypotenuse, so that's A over C. And then tangent is opposite over adjacent, so that's B over A. Now that works if I'm talking about this angle. Obviously, if I was talking about this angle up here, which would be something different, maybe you call it angle alpha, whatever, then we have different opposites and adjacents. And so our equations over here would change. But just kind of make it easy, we're going to be talking about theta down here. So let's try a little sample problem. Let's say it'll be the sun. The sun is shining down across this building, and it produces a shadow which is 67.2 meters long. And when I look up to the sun or look down from the sun, it's at a 50-degree angle. And so I have a nice little right triangle because this would be my right angle down there. Stop doing that. This would be my right angle down there. And so I should be able to kind of figure everything out from there. So as I work this out, I need to figure out the opposite side, and I know the adjacent side to this angle. So opposite, adjacent, opposite, adjacent. I need to pull out my TOA. So the tangent of this angle would equal my opposite side over my adjacent side. So the tangent of my angle, 50 degrees, would equal my opposite side, B, the height of the building, which I don't know, over 67.2 meters. I just have to solve for B, so I'm going to multiply by that 67.2 meters times the tangent of my angle. And that should tell me how tall this building is. Now, on my lovely scientific calculator here, I need to make sure that I am putting it into degree mode. So if I hit the mode button on here, it's going to have all this lovely stuff pop up. And the one thing that I want to make sure is on there is I want the word degree to be highlighted. Right now, degrees is highlighted and I'm good. You also notice at the top, it'll say normal, float, auto, real, degree, MP. That's kind of be the standard that we would want. So if you don't know how to change that on your calculator, make sure you do. So now I can take 67.2, multiply by the tangent of 50 degrees, and I get an angle. This tells me that this is 80.0858, blah, 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 blah. But I would probably count this off to just 3 sig figs. I like to use the number in my number or my measurement as opposed to my angle, even though they're both 3 sig figs. So I would round this to 80.1 meters, and that would be the height of the building. Bam! We just did a physics problem. We just did a geometry problem. We just did a trig problem. Let's keep moving. Another thing I like to point out is SOHCAHTOA will also allow you to find the angle. You just have to use the inverses. So we're going to use the inverse sine, the inverse cosine, or the inverse tangent, but it's still the same. So if I want to find an angle, I'm going to take the inverse sine of the opposite over hypotenuse, or the inverse cosine of the adjacent over the hypotenuse, or the inverse tangent of the opposite over adjacent. So all of those will allow me to find an angle. If you want to write this again as another SOHCAHTOA, you can. I don't think you need to. Last but not least is Pythagorean theorem. So Pythagorean theorem, probably the most known geometry equation of all time. The fact that the hypotenuse squared is equal to the sum of the other sides squared. So a squared plus b squared equals c squared. That's why we use a, b, and c. Great way of relating the three sides. If you at least know two of them, you should be able to find that third side. So let's finish out with another little problem here. Let's say, move me out of the way, I'm going to put myself on the shore, that they kind of make this lake by cutting this section down at a particular angle. So my lake just goes down at a nice constant angle like that. And I would like to know what that angle is. So when this fisherman is out 19.7 meters from shore, the depth of the water is 6.09 meters. That's what I'm going to use to answer this particular question. So what I have here is a nice right triangle. There would be my right angle. I'm assuming the water is going to be nice and flat and horizontal, and the depth would be my vertical measurement. I don't really know the hypotenuse of this triangle. I don't really care. And I'm after the angle. So this is what I was mentioning about sine, cosine, tangent. I can still use tangent on this one because I have the opposite side and the adjacent. But since I'm trying to find the angle itself, I'm actually going to take the inverse tangent of my opposite side over my adjacent side. In essence, what we're saying is that the tangent of my angle is equal to the opposite side over the adjacent side. And then I'm just taking the inverse to actually find it. So I pull out my handy dandy calculator. I'm going to put that on there. I'm going to go second tan. So I'm going to hit second tan on there. Look at that. Boom, boom, boom. Of 6.09 divided by 19.7. Ka-chunk. And it tells me that it's 17.17831702. I would probably round this off to just 3 sig figs and just say 17.2 degrees. But all those numbers are nice and important. So that's first part. Second part, how deep is it over here? Now, I have a couple of different ways to go about this. One way of doing this is I'm talking about it a different boat. Let's come down. Let's change this color here. Let's go to red. Is we could say all the way from here to here is now this 30.2, and I'm trying to find this distance. But this angle is still the same, so it's this 17.2. So I should be able to find this distance using tangent again, because the tangent of my angle would equal the opposite side, which would be D in this case, over this new adjacent side, this 30.2 meters. Could chunk that out. The angle I would use would be the 17.2. I'm good. However, some people will notice that the blue and the red triangle are similar triangles, meaning that I can actually set up, they all have the same angles because they would both have a right angle here. They both have this angle here. And actually this angle over here would also be congruent because they have to add up to 180 degrees. So with that in mind, if I set up similar triangles, I know ratios of sides are the same. So if I'm after D, I might say that D is to 30.2 on the red triangle as 6.09 is to 19.7 meters. So I could set up something like that and solve for it. But here's the really cool part. Notice I just wrote this. Hey, look at that. Oops, I made myself big. Hey, look at that. 6.09. That's the same thing as tangent. So it really is doing the exact same thing when you do similar triangles. Mind blown. that pretty much is the trig that we're going to need to know here in physics class. So I hope you enjoyed and I hope it makes sense. Take care.